In today's lesson, we'll be learning how to convert factored form to standard form. In a previous lesson, we learned that a quadratic relation is just a type of pattern, and this pattern can be represented with an equation. This equation can be in factored form or standard form. In factored form, the variable of a tells you the direction of opening, whether the parabola is opening upwards, smiling, or opening downwards. Meanwhile, the variables of r and s are related to the x-intercepts. Remember, you have to change signs. In standard form, the variable of a tells you the direction of opening, while the variable of b doesn't really tell you anything useful about the parabola. The variable of c tells you the y-intercept. You can convert factored form to standard form using the process of expanding. You can go from standard form back to factored form using the process of factoring. Today we're going to be focusing on expanding. In our first example, we have an equation of a quadratic relation in factored form. We want to convert it from factored form to standard form using the process of expanding. The table to the right is going to help us do that. We're going to start with the variable of x and we're going to place it over here. Next, we're going to take positive 2 and we're going to place it over here. Next, we're going to take the variable of x and we're going to place it over here. And last, we're going to take -6 and we're going to place it right over here. We're going to start by multiplying this term with this term, and the answer is going to go in this empty box. Since we're multiplying terms, that means we're going to be using the product rule. The first step of the product rule is to look for coefficients. There is no coefficient here and there is no coefficient there. If there is no coefficient, that means there is a hidden 1. And we want to multiply coefficients. So 1 times 1 is going to give you 1. Next, you want to take a look at the bases. There's a base of x here and there's a base of x here as well. Bases stay the same. So this is going to remain x. And last, we want to take a look at exponents. There is no exponent here and there is no exponent there. There is no exponent. That just means there's a hidden 1. And we want to add exponents. So 1 plus 1 is going to give you 2. We're going to repeat this process by multiplying this term and putting the answer in this empty box. First step is to look at coefficients. We already know the coefficient of this term is 1, but what about that? The coefficient there is positive 2. So we want to multiply coefficients. So positive 1 multiplied by positive 2 is going to give you positive 2. Next, we want to look at bases. We already know that the base here is x, but there is no base over there. Bases stay the same, so that x is going to stay the same. And last, we want to take a look at exponents. We already know the exponent here is 1, and there is no exponent there because there is no base. So this 1 is going to stay the same. So I'm going to write a 1 as an exponent over here. I'm going to repeat this process again by multiplying this term and writing the answer in this empty box. The first step is to take a look at coefficients. We already know the coefficient of this term is positive 1, but what about this term? The coefficient there is going to be -6. We want to multiply coefficients. Therefore, -6 multiplied by positive 1 is going to give you -6. Next, we need to take a look at the bases. We already know that the base here is x, but what about here? There is no base. So that base of x is going to stay the same. So I'm going to write x over here. Last, we want to take a look at exponents. We already know the exponent of this term is 1, but what about this term? Since there is no base, that means there is no exponent. So that exponent of 1 is going to stay the same. So I'm going to write a 1 right over here. We're going to repeat this process one last time by multiplying this term with this term and writing the answer in this empty box. This should be a little bit more straightforward since you have -6 multiplied by positive 2. And that is going to give you -12. At this point, we're going to take these 4 terms and place them in this bracket. That means I'm going to recopy 1x to the power of 2, positive 2x to the power of 1, negative 6x to the power of 1, and negative 12. At this point, you want to look for like terms. Remember, like terms have the same base and the same exponent. These two terms would be like terms. When we combine these like terms, we're going to get negative 4x to the power of 1. Remember, the bases are going to stay the same and the exponent is going to stay the same as well. This 1x to the power of 2 is going to stay the same since we haven't done anything to it. And this negative 12 is also going to stay the same since we haven't done anything to it as well. Since we have a number in front of a pair of brackets, that means you're going to be using the distributive property. So everything inside the bracket is going to get multiplied by positive 1. But anything multiplied by positive 1 stays exactly the same. So that's going to stay exactly the same. This is going to stay exactly the same. And this is going to stay exactly the same. Let's clean this up. Remember, we don't like to see a coefficient of 1. So I'm going to erase this coefficient of 1. We also don't like to see an exponent of 1. So I'm going to erase that exponent of 1. So what we've just done is we've converted factored form to standard form.